Hello friends, welcome to Risingpearl.com. Today we are going to take a look at question number 15 that appeared in 2016 CBSE Class-X Math exam. Now at the onset, at the very beginning, I must tell you, I personally found this question to be the hardest in the entire test. Now we all, depending on our preparations and our practice, we will know we may have different questions that we find to be more harder compared to the other questions. But for me personally, when I went through all the questions, I found this question to really stand out in terms of how complex this question was. So let's take a look into it and see how we can solve this question. If the ratio of sum of first n terms of two arithmetic progressions, we don't have one, we have two arithmetic progressions, and the ratio of the sum of first n terms of these two progressions is given by this, which is 7n plus 1 is to 4n plus 27. Find the ratio of their mth terms. Now normally we take the first term of any arithmetic progression as a, and the common difference is d. This is the convention, we always take it like this. And then if we do that, the nth term of an AP, we find this using the formula a plus n minus 1 times d. I'm going to provide all the formulas and the proof of these formulas on the upper right hand side corner of each of these problems. So the nth term is found by using this formula. Also the sum of first n terms is used. We use this formula to find out the sum of first n terms, which is Sn equals n by 2 number of terms by 2 times twice a plus n minus 1 times d. Now these are things which are known to us. These two formulas are known to us. Now what is given is we have two arithmetic progressions. So while we can use this for the first arithmetic progression, we need a second set of first terms and common difference. So let's assume for the second series or second arithmetic progression, first term is p and the common difference is q. Now I totally understand this is not convention, but keep in mind we have no way of knowing any relationship between the first term of the first arithmetic progression and the second arithmetic progression. Similarly, we have no way of knowing any relationship, if at all, that exists between the common difference of first AP and the second AP. So we have to take separate first terms and separate common differences. So this is basically first AP and this is our second AP. Right? Now, what is given to us is that if we take the sum of first n numbers of first AP and divide that by sum of first n numbers of second AP, this ratio is given by this, which is 7n plus 1 by 4n plus 27. This is given. So if we use this formula, then what this really means is that, so let's do it here. So for the first AP, the sum of first n numbers is given by n by 2 times 2, the first term is a, plus its first n number of terms, so it is n minus 1 times d. Now this divided by, for the second AP, the sum of first n terms is n by 2 divided by 2, first term is p, so it will be p instead of a, plus n minus 1 because the sum of first n numbers, so number of terms minus this, and common difference is q. Now n by 2 can cancel out. So what we have is we have 2a plus n minus 1 times d by twice p plus n minus 1 times q. And this ratio is what is given as 7n plus 1 by 4n plus 27. This is what is given, right? So what we have is 2a plus n minus 1 times d divided by 2p plus n minus 1 times q. This is equal to this. Now we are going to focus on the ratio of the mth term because that is what we really need to find out. So let's look into that next. So the mth term for the first AP will be A plus mth term, so it will be m minus 1 times d. Now this will be divided by, because we are finding out the ratio, divided by p, first term of the second AP, mth term m minus 1 times q. Now what we are going to do is we are going to multiply the numerator and the denominator by 2, and you will see why we are doing that. We can multiply the numerator denominator by same number for a fraction. It doesn't change the fraction. So if we do that, what we will have, let's write it here, we will get 2a plus, now 2 times d times m, it will be 2md minus 2d, and denominator similarly will be 2p plus 2mq minus 2q. Now if we take d common here, so we will have 2a plus, if we take d common, we will get 2m minus 2 times d divided by, we will have 2p plus 2m minus 2 times q. Now what we are going to do is we are going to write this little differently, and you will see why we are doing that. So it will be 2a plus, now 2m, instead of minus 2 we are going to write minus 1 times d, because it's minus 2, so we are writing minus 1. Similarly, whatever we are doing in the numerator, we are repeating the exact same thing in the denominator. So it will be 2m minus 1 times q. The reason we are doing that is because we want to group this separately like this. So at this point we have this, correct? So at this point we can multiply again both the numerator and denominator by, we can multiply, so let's see, this is the numerator and this is the denominator, right? We can multiply each one of them by 2m minus 1 divided by 2. So we can multiply this by 2m minus 1 divided by 2. So where did we get this from and why are we doing this? For a moment, if you ignore this, if you notice just this part, this is looking like, remember, the sum of first n number of terms, Sn, is equal to n by 2 times twice the first term plus n minus 1 times d. So the sum of first n numbers is n by 2 times twice a plus n minus 1 times d. It is this value that we have over here, which means that twice a plus something minus 1 times d. So something minus 1, so this is the formula for n number of terms. So here we are getting something minus 1. So what is this something? The value of something is twice m minus 1. So we are trying to make this the sum of first 2m minus 1 number of terms, right? So in other words, if now this, again keep in mind that m is a number, right? So this entire thing will be a number, and so is this. So we can actually multiply both numerator and denominator by this because they will actually cancel out. But by writing it this way, we can say that this entire numerator now is looking like sum of, this is looking like sum of first twice m minus 1 number of terms for the first AP divided by sum of twice m minus 1 number of times for the second AP. I wanted to pay close attention to the fact that it is 2m minus 1. So instead of n, we have 2m minus 1, right? Because n is a value, n is a number of terms. Instead of having n, we have 2m minus 1. So in other words, if we were given that a arithmetic progression has some amount of terms, find out the sum of first 2m minus 1 number of terms. So we would have exactly written that 2a plus 2m minus 1 minus 1d times the number of terms 2m minus 1 divided by 2, right? So in other words, let's give ourselves a little bit more space. So what we have is, we have 2, let's write it this way, so 2n minus 1, the number that we actually multiplied numerator denominator, this by 2 times we have 2a plus 2m minus 1 minus 1 times d. This is what we have. This entire thing divided by 2m minus 1 by 2 times we have 2 times p plus 2m minus 1, this minus 1 times q, right? So this is nothing but sum of 2m minus 1 terms, sum of first 2m minus 1 terms for the first series divided by sum of the first 2m minus 1 terms of the second series. But we know that they actually are given by this formula. So we can say, if that is true, then instead of n, we can replace n by 2m minus 1. So this ratio should be equal to 7 times 2m minus 1 plus 1, 7n plus 1. So instead of n, we are putting 2m minus 1 by 4n, instead of n, it is 2m minus 1 plus 27, because we have plus 27. Now if we simply solve this, we will have 7 2s are 14. So this is 14m plus 7 divided by, this will be 4 2s are 8m. 8m, actually this should be, we made a mistake here, this will be 14m minus 7, 14m minus 7 plus 1, 14m minus 7 plus 1, and this will be 8m minus 4 plus 27. So in other words, this should be equal to 14m minus 7 plus 1 will be minus 6. So 14m minus 6 divided by, we will have denominator will be 8m plus 27 minus 4 will be 23. So if we have not made any mistake along the way, so we will get this as 14m minus 6 divided by 8m plus 23. So this should be the answer for what is the ratio of their mth terms. So friends, this is how we solve the question number 15, and as you can see, it was not very straightforward as we would have expected this to be, and we really had to use some of the imagination and relate the mth terms to bring it to the sum of 2m minus 1 term, and then use the ratio which is given to find out the actual ratio of the mth terms of the two arithmetic progressions.